Welcome to the third video of Module 4 on logarithms. In this video, we'll be looking at applications of logarithms and exponential equations. Here I'm going to briefly overview a few different cases where logarithmic and exponential equations are used. The first example is the pH scale. Each decrease in pH by 1 pH unit means a tenfold increase in the concentration of hydrogen ions. We can express pH as being equal to negative log of base 10 of H plus, which is your hydrogen ion concentration. In the decibel scale, for each change of 10 decibels, there is a tenfold change in the intensity of sound. Therefore, if normal conversation occurs at about 60 decibels and a heavy truck makes a noise of 90 decibels, that is a 30 decibel difference. That means that the truck is 10 to the power of 3 times louder than normal conversation. That is, that it's 10,000 times louder. The equation for decibels can be expressed as 10 times the log of V over V sub 0. The Richter scale uses a logarithmic equation to measure the intensity of earthquakes. Earthquake magnitude is measured from 1 to 10, wherein each change of 1 unit in the Richter scale changes the intensity of an earthquake by tenfold. R is equal to log of I over I sub 0. Population growth and radioactive decay are both examples of exponential equations. Bacterial growth that's not limited by space, food, or other resources tends to be exponential. We can see that the population is proportionate to the size of its current population, where P sub 0 is the initial population. Because we're discussing a population growth model, we need to make sure that B is greater than 1. Radioactive isotopes decay according to a decreasing exponential growth function. We can calculate the amount present at time t given an initial amount and a rate of decay, where R is defined as being less than 1 since it is a decay problem. In some future videos, we will look at calculating the half-life for a radioactive decay problem. And we will look at how the same amount of time is required for a radioactive mass to reduce by half, regardless of the amount, A sub 0, that we initially have. These 5 examples are just some of the cases where exponential and logarithmic equations are used. In the next 2 videos, we'll use the properties of exponential and logarithmic functions to solve various application problems. The first video will be related to exponential growth and decay, and the second will be several examples with pH.